Yes, thank you. Thank you, Alejandro, and all the others for hosting this nice workshop. I'm going to talk about Pixi, which is a cross-language, cross-platform workspace manager, and we at Prefix are building it. But uh, first, let's actually escape this and show you what you can do with it. So I'm going to quickly give you an example. I hope this is actually viewable for you. I'm going to clone a repo. In this case, it's our own repo, Pixi, but it has some examples. So I'm going to go there. For instance, ROS2. You know how hard it can be to install ROS on your system. But if I just do pixi run start in this uh, repo, you'll see that installing ROS can actually be pretty easy. And I hope you trust me that ROS was not on the system before. I only have a cache of the packages on my system, so we're not blocked by downloading. But what you can see is that we now have Arvis running. And I just cloned this repository, and now we have Gazebo running. So some of you might actually know how hard that could be previously to get started. Of course, there's some warnings and errors everywhere, but let's not get bogged down by that, because there's also something else we can show. For instance, rerun. It's some of the tools that you've been using probably these days if you're using the new cool stuff. But let's just do a pixi run new skins, which is something that I found under example repository. This will actually install the packages as well. I was hoping that it wouldn't start downloading, but apparently I cleaned my cache just before it. So let's go back to the other example as well. Maybe it's fast enough. Oh, I made a mistake in my typing. Let's get it running. Okay, sorry. Let's skip that example then, because that's going to download a lot of stuff. Let's go back to the presentation, which is here. If I click the right buttons. Always annoying when you're doing a demo. Come. So that was fun, but what is actually our goal? So what we want you to be able to do, just like you saw me just doing, less time in setup and more time in playing with robotics. So we don't want you to have the experience of it worked on my machine, but yeah, now it's not working on your machine. We don't want you to have nightly CI failures because someone in the world updated something somewhere, but we want you to be able to develop, test, deploy, all of that with confidence. And we don't want you to need VMs and full images to recreate your environments. We just want you to work on your host. We don't want you to dual boot your computer to get it working. Let's just make it like normal. But first, who are we? We're Prefix.dev, and we're trying to solve package management. This means that we're going all the way through all the stages of package management, and today I will show you Pixi. We're all ex-roboticists, or the most part of the core team is there currently. We came out of the ROS ecosystem, as some of you probably know, and we're all definitely open source enthusiasts, and that's why we continue working on these projects fully open source and with everyone to share. If you want to follow me, you can find me at Ruben Arts on most platforms. So what do we actually want to change, and what process do we want to streamline? So if you develop in an isolated environment, you're much easier to share this around. So what you just saw me doing was develop locally something, get it running, share it with the world, and then Git cloning something in, and that all works. We want you to do that in a lightweight setup, so you don't want you to have the need for Docker or VMs to get it started. Then as soon as you're done with development, you want to test this stuff. So you need it to be extremely easy to get it running in CI systems or on machines, and make it easy to get started with other people in your team. For instance, the testers might not be the same people as the developers. So everyone needs to understand the same simple language. And then last but not least, we want you to deploy directly to host. So if you put a robot in the field, or if you test on a local machine, you want to be able to do that on the host itself to get all the power of the machine ready. If that is your goal, if you want to use Docker images or anything else, that is also still possible. It's just that we can go a step lower, close to the hardware. So that's one of our biggest goals. But how does that work? How can we be able to do that? So the reproducibility we're focusing on comes from log files. So we'll always produce a log file. These log files can be shared with others, and that makes sure that when you reinstall something, you will get the exact same environment every time, and you will download the packages that the other person or yourself in the previous time had on their machine. And then we don't just install it globally on your system. We will not break your system because we do a new installation. We'll put them in isolated environments, which are just folders on your machine, and there they will not interfere with each other and will not break your system when you install it. And then we make very good use of the Conda ecosystem. And if you didn't hear of that yet, it is a cross-language package management system initially built for Python package management, but it's much more than that. It can do C++ management, Lua, Rust, what we use, and all of that is available through the Conda Forge community channel, which makes it possible for anyone to upload packages, but with a little bit of scan before you can upload. So it's not a similar experience as with PyPI, where you can just push whatever you want to the channels. But in Conda Forge, there is a community set up, so people get reviews on their packages, so we don't get too much junk on there. And I really want to mention RoboStack. That is the one that makes it possible for ROS installations on through pixi. And we have a few people, I believe, that are very close to this project, called Tobias Fischer and Silvio Travisaro, which are huge contributors to the RoboStack and build a lot of these packages. So it makes it a lot easier to get my example just running, because ROS can be a very hard system to set up initially. This is a growing system, so all your contributions are welcome. We're still testing a lot of the new stuff. New versions of ROS are coming online, etc., etc. But it's growing as we speak. So how do you get started with pixi? You can simply install pixi with one command. It's a single binary. This will run a script that downloads a single file and puts it in the right place. Then you can clone any project like I just did and run the pixi command, pixi run start on it. And that will install the environment in the correct place, will get a task that you defined, because start is probably just an alias for something else, and get it running. And this experience is then shared because all the pixi projects that you have in your team or collaborate on. But if you want to start a new one, it can be as simple as pixi install pixi init and then the project name. Go into that folder that pixi created for you. Run a command like pixi add to add a certain package to it, and you can immediately use it in that specific isolated environment through the pixi run command, which can run any command in those environments. So what did just happen when you run these commands? It will first create the manifest for you, which is a TOML file that contains all the declarative instructions to create these environments, and it will include the tasks. And this can be very powerful with different levels of environments, different levels of tasks that you want to run. This is also heavily used by the group that made the VSLAM-LAB repository, which is a great place to get one solid input to a tool to get it running for all your configuration. Then the log file is the one that is created by pixi when you run pixi install, for instance, or pixi log, which will create the exact requirements needed for your system to install. And then next to that, it will actually install that into that virtual environment close to the project. So this will be in the folder of your new project, and it will if you remove this folder of your project, it is also gone from your machine. So you will not get in trouble when you need to know where your files are going. So what do the files look like? The manifest looks like this. So it's a very simple example, but you have to define which channels you will be using in the workspace. So in this case, my example is Conda Forge. Then the platforms you want to support, because as I said, pixi is cross-platform, we have to define which platforms you want to support with your project. That means that pixi will create a log file for these platforms and will make sure that everything is in sync. So if you add a dependency, but your project actually also supports Windows, it finds out this project cannot be installed on Windows, it will warn you before you continue all of your development, thinking that you will be able to recreate this on all the other machines you want to support. And then you can have tasks, which can be very simple and just basically an alias. For instance, build would be make build. If you run pixi run build, it will run this command in your environment. If you want to go a little bit further, you can actually have a much more declarative version of those tasks, for instance, with a dependency. So you can, if you run pixi run start, you will depend on the build task first. And this way you can set up complete graphs of different tasks that you want to work with. And then last, the dependencies are very important. So pixi will log all the dependencies that you added to your project with a certain pinning, but here you can also modify them by hand. So this file is definitely meant to also be modified by hand. That is not the case for the log file. So the log file is the exact requirements file, which will definitely log everything down to the specific URL where to get the package from, even with a SHA hash and license information and everything like that. So you will be able to really recreate your environment on any of these machines. So it will also log it down for all the other platforms. And if you have multiple environments, it will log all of them into one file, which is easy to share through, for instance, Git. Then the virtual environments can be a little bit spooky sometimes if you get started with it, but it's simply just a folder that contains a Linux-like setup of your tools and binaries, and that could look like something like this if you install Python. So the binary files are in there, all the libraries are in there, and the tools themselves, for instance, the Python interpreter will know how to deal with it. Pixi run or pixi shell will activate these environments for you, and you will not have to really think about the structure anymore because that's all handled through the pixi toml file. So how is this actually great for robotics? And why do you want to use this tool instead of other options? One of the major benefits of Pixi and Conda in that case is the fact that you can run it on any of the machines. So in this case, I'm showing it to you on a Mac machine, which is actually not really supported by ROS, but we could make it possible through the installation through Pixi. The same thing goes for Windows and Linux. But you can also do it for any language. So if you use Python package managers like pip or UV these days, you are pretty limited in the terms of what you can install. For instance, you cannot install the whole ROS ecosystem through pip, but you will be able to do that through Pixi and the Conda ecosystem. And this goes much further than just robotics. This can go into data science. We have a huge user base there that are currently using it a lot for machine learning and stuff like that. So these tools are really benefiting from the ability to install on any system and make it a one clean setup for you to use. And one thing that's really important, I have been working in a robotics company. One of the biggest issues we had was I am developing something, a tester is trying to test my code. They have to update a robot in the field or in the test environments, and they are getting in trouble because some dependency was different from their environment versus my environment, and now they spent an hour on figuring out which dependency that was and how to get it properly installed. With these Pixi environments, you just create another folder, you just reinstall, and everything will be exactly the same in development and in testing. And that is an experience that was really game-changing for the development speed of our robotics systems. Want to mention a few big projects that are already on Pixi or using Pixi for their development. So you might know FreeCAD. It's an open source computer drawing system that you can install. But for their development, they already use Pixi to build everything. You might have heard of Mojo, which is a new language by Modular. They completely changed over, not for building Mojo, but all their Mojo packages are used through Pixi. They call it Magic, but they just renamed Pixi. And there's also Rerun, which I just wanted to show you, but my example was trying to download stuff. But there's this really cool visualization tool to debug all your, for instance, visual SLAM stuff, or other great robotics use cases. And of course, ROS2. They are not fully on Pixi yet, but their Windows builds are currently using Pixi in the backend to make them more reproducible, and hopefully more and more of these things will be changed over to actually also using Pixi to just make it easier for everyone to use ROS and that whole ecosystem. So I was really quick. Thank you for joining this talk. If you want to know more, go to pixi.sh or our website, Prefix.dev. You can also follow us on all of the social media channels. And we also have a Discord, and I will share it in the Discord of this presentation later. So you could join if you have any questions. We're very open to anyone joining in. Everything that we build is open source again. So if you have any issues, please contact us through the GitHub links or anything else. And I think there's still time for a few questions if there's any.
Thank you, Ruben. Yeah, there is time for one question. Any questions in the room? I do have one question. Ruben, is still there?
Yeah, then good luck with the rest of the presentations.
Playing a lot with pixi and implementing a lot of stuff, DPR baseline, SLAM baseline, and it's super helpful. So I guess it's very helpful for roboticists and computer vision people. But we were wondering, how is this useful for other people outside these communities? Like, for example, to, I don't know, scientists, biologists. Do you have any examples for that?
Yeah, for sure. Of course, sorry. Actually, we're just getting into robotics right now because it's the hardest problem to solve. We already have a huge user base in data science specifically, and especially bioinformatics and stuff like that. So if you go to pixi.sh, you can go to the community list. And there's a few packages that are already switched over to fully using pixi. One of our bigger projects that are really cool is ModFlow, which is used for all data science around water management. There's also Quantco uses it for a lot of stuff. So they are doing a lot of data science and using Python ecosystems mostly, but want to really recreate them at the clients. So they use pixi for that. Let me see. Yeah, there's actually somebody probably related to your projects as well. Pablo has done a lot of great projects using pixi. So some of his work, like Mini Duster, is also using pixi to get it to run. Sorry, I clicked the wrong button. So stuff like this, for instance, which is probably very close to what you guys are all doing. And just making that work on multiple systems is a breeze to see, compared to when I was studying robotics and had to deal with dual boot on my machine.
Well, thank you very much, Ruben, for joining us today.